Hi, this is Haruna.
Hi, this is Rashmi, and welcome to Integrating 3D Modeling and Printing in Your Classroom, Session 2 Introduction to Tinkercad.
And our course website is at tiny.cc/bps3D printing, and you'll find some of the resources posted there that we'll go through during this webinar.
Today's agenda, we'll be covering how you log in onto Tinkercad, the Teach tab on tinkercad.com, how to create your accounts for students under 13 years of age.
We'll also go through all the interface and the tools within Tinkercad.
And then we'll talk a little bit about the assignments for session 2 and how you can submit your assignments.
All right, so moving right on to Tinkercad.
Okay. So this is how your login page for Tinkercad looks like when you go to tinkercad.com. And in here, if you go to the Teach tab, you will see that you can sign up for free, of course, and you can use the invite code and share it with your students, especially for students who are under the age of 13. And you can also preview your student design as they are included in that student group for the Tinkercad class. So let's go to the upper right corner, and this is where you sign up. I'm just going to sign in using my account, and I've used my Boston Public Schools account to log into my Tinkercad. So this is where you get the main login screen, and this is where you will see all the designs that you are creating, and they will be saved up here. Right on the right hand corner, you will see the profile that you can go in and edit, and here you can add different information for your thinkware, shapeways, all of those, save your changes, and then you can go back to the main menu on the Tinkercad page. Create new design allows you to create new design in Tinkercad. And right here, this is the place where you'll be working. As you can see on the left hand side, it's giving you really creative, innovative names. So the first thing you should do is change the file name to something that you're creating. So say my first project, or whatever else project you're creating. On the left hand corner, you can see that's your home view, which gives you, if you press on it right now, we are on the work plane. This will zoom in the work plane, so I can zoom it further. I can zoom out, but if I go into the home view, it will automatically give me the full perspective of the work plane. And then in here you also have this cube, which will allow you to see the top of your design. So let's drag in the cube so you can see what I'm talking about. So this is the top view of your design. You roll, this is the front view, the bottom view, and so on and so forth. You can also do that with the trackpad options on your Mac, so you can zoom in. Let me put it this way. So if I use two fingers to zoom in, like so, and I can use two fingers and click to rotate and move my plane. So, yeah. Yes, so those are your two key options. So let me get back to, yeah. And in here, you also have the work plane, which is the work plane that you're working on. And then you have the ruler, which is right here, which you can drag onto your work plane. But before that, I also wanted to show you on the right hand corner, you have this edit grid, which allows you to see the units of millimeter and inches. So you can choose the inches or the millimeter grid, and you can update your grid, and that will change accordingly. So let's go back to this. We looked at the ruler, we placed the ruler, so all you have to do is click and drag onto the onto your work plane, and you should be able to see the ruler and can place your objects around that. So let's get rid of the ruler. And quickly, this is the menu for your basic shapes. And you can see that in here you have multiple shapes that you can drag and drop onto your work plane. You can also take a look at the text. So you have letters, you have text that you can drag and drop, and you can rotate it around. Or you can go into symbols, and you have different symbols that are already here that you can use, or you can create symbols and add it to the library as well. And then there are connectors and extras that you will be playing with in our future webinars. Thank you.
Okay, so now that Rashmi has shown you all the interface within Tinkercad, we are going to actually go into looking at the different shapes and actually designing something. So, so Tinkercad consists of all these different blocks, and the basic design happens by dragging these shapes, geometries, and combining them or subtracting one from another. So let me first drag out a box. There we go. And first thing you'll notice is as soon as you drop something onto your work plane, you get all these options on the right side. Depending on the shape that you drag out, you'll get a different set of options. But in the case of the cube or the box, we can change the length, we can change the width, we can, that made it too skinny, we can also change the height. And these are all in millimeters since my grid is in millimeters. Whoops, made it a little too big. I can also round the corners by increasing the radius. And you can kind of see how my box gets a little more rounded. And the steps is how many sections that radius is drawn in. So if I shrink that, you can see that I get more like a boxy type of rounded shape. And as I increase the steps, you get a smoother rounded corner. I'm going to bring these back to 0. So we can resize things based on this toolbar, or we can also resize it right on your work plane. And to do that, you need to grab one of these white squares. So this top one will change the height. If you click on the white square and move it up and down, and the ones on the base will change the width and the depth or the length. You can also type things in if you want to precisely change the dimension and not having to tweak the mouse trackpad really precisely. So you can click on it, click on the number, and change the dimension by typing in the number. So the white squares that you see on the corners are for resizing. The other handles you see, you might notice this little tiny black triangle on the top. This actually moves it up and down along your work plane. So right now I'm sinking it into the work plane. Now I'm bringing it up. And the distance that it moves by is shown by that it's down here. So right now my cube is 19 millimeters above the work plane. I'm going to bring it back to 0. You can also move it side to side just by clicking on it and dragging it around. You can also rotate it by looking at these arrow handles. So this, if you click on this, you can rotate it around the X and Y plane. And if you click here, it will rotate it in the Y and X and Z plane. And this will move it on the Y and Z plane. So there are 3 of these handles. And you can move it and rotate everything accordingly. So that's the different things you can do to a geometry. Now let me drag something else out. I'm going to bring out a cylinder. And you notice that now I have a different set of choices. The bevel will add a rounded corner type things to the cylinder. And the size actually, in this case, refers to the number of sections along the radius, along the circumference of the cylinder. So if I shrink it, my cylinder will become more like This is 12-sided, so it's not a very smooth circle. If I increase it, I get a smoother circle. And, whoops, I zoomed out a little too much, hang on. And the segment you see here is the number of segments within this rounded bevel. So if I increase it, you get a nice, rounded corner. If I decrease it, I get a straight beveled edge. So now, let's see, I have two geometries on here, and again, with the cylinder, you can resize it. You can also make it into an ellipse. You can also move it up and down by grabbing on the dark black, the solid black arrow on top. And you can also intersect it with your existing shape, and that's how you would start building more complex shapes. We also have alignment tools. So let me zoom out so you can see the alignment tools. To use the alignment tools are actually up on top. You need to highlight at least two geometries, and this will become available. You click on the align tool, and it gives you all these circles. So this right here means it will align it to the work plane. This middle one will align the center lines in the vertical direction of these two geometries. So if I click on that, my oval moved up a little bit. This will align everything to the top. So now my my oval moved up even more. I'm going to leave it in the middle right here. And same thing with these. This will align everything to the left, align to the middle, align to the right. So left, center, right. And if I twirl around to the other side, I have the remaining three handles, so I can align to the back side, I can align to the middle, I can align to the front side. So using these tools, you can align things and make things symmetrical if you need to. So if I want this to be symmetrical, I can click on align in the middle, and I have a symmetrical aligned object, like so. Anytime you click on a shape, you will notice that there is a solid option and a hole option. Solid means, obviously it's a solid. The hole option means you're subtracting that material. So if I click on my cylinder here and make that into a hole, it will come out to be this transparent, transparent color here. And now it's basically going to cut into my rectangle, into my box. And you can complete that operation by highlighting both of them and hitting this group button up on top. I group them together, and now I end up with one shape that has a cutout in the box. And I can always undo that, ungroup it if I want to. And the difference between the grouping and ungrouping is if it's ungrouped, I can manipulate individual objects, and I can move this around. If I didn't quite have it in the right place, I can change it around. And then when I'm ready to finalize it, I can group it together. Once it's grouped, I can't manipulate my hole anymore. This is all one thing. But now it's much easier for me to work with this one shape. So you want to kind of be careful with when you group things and when you ungroup things, depending on what you're designing. You don't necessarily have to group anything together. You can have multiple ungrouped geometries and export everything as one solid. But just for your ease of use, sometimes you do want to group things together. So right now I'm just going to ungroup because I don't need it to be grouped. A couple of other things I do want to show are the text options. So Rashmi showed you the text. There are individual letters, and there is also this one thing that says text. And there is a difference between those two, so I do want to point that out. The individual letters, obviously you can drag it out and move things around one by one. So, you can put them together and, whoops, I can't zoom in, there we go. And place them wherever you want. You can have one letter bigger than the other, you can manipulate them. With the text, you can type things in, so it makes it a little bit easier to do longer texts. However, once it's there, you can't manipulate individual letters. So if you want these letters closer together, or if you want one letter bigger, or if you want one of them taller, you can't do that if you use this text option. You need the individual letters in order to do that. And this is actually important if you're making something like a keychain. You're tempted to just type it in like this, but then each letter is a separate solid if you print it out. And they're all disconnected. And if you need all the letters connected so they can print as one piece, you actually need to use the individual letters. Of course, you can still use the text and have like a background piece that joins everything. That's fine too. But you just need to remember that when you do this text option, all the letters end up separately. A couple other things I want to show are some more of the tools up top. So right next to the alignment option, there is a flip option. So if you click on a geometry and say flip, you get these 3 arrows. And it will flip things in that direction. So if I click here, it'll flip things in the X direction. So you can see that. I can also flip up and down, and I can also flip in the Z direction, which in this case, it doesn't seem to be doing anything because it's actually symmetric in the Z direction. So that's your flip option. What else? I think I have gone through all the tools that I wanted to show you. So those are the very basic introduction to Tinkercad, and really the tip now is to play with it, and using those simple tools like grouping and using the combination of solids and holes, you can build a more complex geometry. Now, once you have a good geometry, what you need to do is export. And well, if you want to print it on a 3D printer, you need to export. So to do so, you click on export, and actually you need to go to the 3D print tab. Oh, wait. No, sorry, they changed this. You go to the download tab. It used to actually go right to the 3D print tab. Now they changed it in a good way, actually. So keep it there. Go to the download tab, and then you're going to select the STL file, which will then generate the file that you need for your 3D printer. I'm not going to actually do it now. And for your assignments, which we'll explain in a second, you need to go to Share, which will then let us generate a link to your project that you'll submit. So you're going to click on Share, go to the Invite People, and generate new link. And that will give you a link. You're going to take this link, cut and paste into the Google form that we'll give you to submit your project. All right. So let me go into your assignments. So for this session, whoops, sorry, wrong slide. For this session, we're going to have 2 assignments, and each of the assignments will have 2 different options. So we're going to tell you 4 different things. You're basically doing 2 of them. For your first assignment option, we would like you to design a character or a hero, either a literary character or an imaginary one. Or design an imaginary insect that contains all the traits of an actual insect. So that's like having 3 body parts, 6 legs, and so on. And that will, we would like you to use at least 3 types of geometries. So that means, a sphere and a cube and a cylinder or something like that. We don't want you to just use three spheres. We also want to see both solid and a hole. And we would like to see some evidence of use of alignment tools. So as an example, I have let me go back to my Tinkercad, and I made a little insect right here. Whoops. Let me click on Tinker this to open it up. So this is an example of an insect. Move this around so you can see a little better. So it consists of a flattened sphere for the head, a hexagon for the body, and a flattened dome, I think. Yeah, half sphere for the abdomen. And then we have these legs are actually inverted letter V's. They're text. And then I have these rings along the abdomen that's actually a hole. And I left them as separate pieces so you can see them better. But if I group all these together, oh, and I also have spheres for the eyes. If I group all these together, you'll see the holes be gone and you can now see the ridges in the body a little bit better. So that's my insect. And let's see, here is it. It is 3D printed. I don't have the rings on the abdomen on this one yet. I printed the wrong version. But you can see that the legs are actually V's. And it's, you can use text in a different way. You don't have to use it as text. You can use it as geometries. So here's my little bug. And if you do this in a science class, then you could have everybody take home an imaginary bug. And if you want to expand it, you could even have them write about it, write about their habitats, write about what their life cycle is, and really get into the insect life cycle a little bit better. And then I'm going to hand it off to Rashmi, who will explain the second assignment options. Stop it. How do I stop this thing? Oh, this.
Hi, so as Haruna mentioned, you saw the assignment 1 option, and now this is the assignment 2 option. So you have 4 designs, out of which you only have to create one, and we'll show you how these designs look like in actuality, so after 3D printing, and we'll also show you the Tinkercad models. So you can either create a stackable polygon structure, or you can create a keychain which illustrates pi or your name. You can also create a scaled model of solar system or part of it, or you can design a protractor model as shown in the picture here, and as we'll show you the model. So you can use any of these models in your classrooms based on how and where you want to place it. Again, the requirements are that at least 3 types of geometries are used, both solid and whole aspect of defining your geometries is used, and also to make sure that you use the alignment tool. So we can see that all of these requirements in your models when you submit it. So this is the solar system model that we're talking about, which is essentially the scale model for proportions. So this here is the sun, then you have the Jupiter, the Saturn, and then the Neptune, and in here you have you can see the little bits of uh, Earth, Mars, Venus, and all of the planets. So essentially this model is used in science classroom as well as in mathematics classrooms to talk about scale and proportions. So this is one of the assignments, and you can do a portion of it, or you can model the whole solar system. The second assignment that we are talking about is this pyramid of polygons. So you have a hexagon. You have the hexagon right here with the pentagon in here, and then I designed this pentagon with a 0.2 mm inches, sorry, 0.2 millimeters spacing, so that this um, pentagon could fit into this hexagon, right? So and then the next object that comes in is the square. So again, a 0.2 mm spacing between that, and this is the square um, with a triangle hole in it. So this goes right in here as well. And once that's done, we had to make a triangle hole inside the square so that you could fit the triangle in here. And you can do that for um, septagons, octagons, decagons. So this is a really great model to teach polygons for K5 and onwards. And the last model I want to show you is that of a protractor. So let me turn it around actually. So these are all different pieces, as you can see. And in here you have a 30 degree, 45 degree, 90, 120, and 180. So you design individual pieces with these degrees, and that's a protractor with a 3D perspective, so students can actually see how these angles work. So we are going to show you a model of that in Tinkercad as well. So now that you have seen the actual models after we have 3D printed it, so here is the look at how these designs or geometries look like in Tinkercad. So the first project will be the polygon tower, which looks like this. So let me quickly tinker this. And in here you can see that the hexagon is designed, and then the hole is that of a pentagon. Of course, I've kept a 0.2 millimeter space between the pentagon and the hexagon so that the pentagon can fit into the hexagon. And the same process is being implemented with the pentagon, because we want to then fit the square into the pentagon and the triangle into the square. So you can do this model um, with more shapes, like as I mentioned before, like the hexagons. After that, you can add septagons, octagons, up to dodecahedrons. Dodecagons. So that was the polygon tower. Let's look at the other assignment, which was that of the keychain. So I have a couple of examples here where you can form the keychain. The first one is this, which is, it essentially has a structure, as you can see, and I'm going to let me um, ungroup these. So as you can see, it has multiple structures, and then you have the rectangle, and then you have um, the hole, which is also rectangle, and then you have the letters in here. So you can obviously change the letters in here and put your names or the name of your pet. There's this structure that I brought in from the torus. You could bring that in and attach it, so that forms your keyring structure. If you want a thin torus, you can do that as well. Just make sure that you group this, and then you have, of course, you can choose the colors that you want. Um, yes, so for me, the colors are green, um, yellow, and blue, but you can choose as you want. So that's one key structure, keychain structure. The other one I wanted to quickly show you was this one right here. This is my neighbor's dog. His name is Henry. So we try to modify that in the keychain. This is also another one which is a very simple one, um, with just letters, so no base. But as you can see, and Haruna mentioned this during our screencast for the Tinkercad, that you should make sure either you have a plate on which these letters are resting so that they're connecting together to a surface, or you can also do this structure where the letters are connecting to each other. This is the name of my kid, so I have just made sure that A is connected to the D, is connected to the I, and then so on and so forth. So when you 3D print it, they're not individual prints but are more um, aligned prints. And you can always add a torus or a different structure to this, and you can have a ring right in here. So all I'll have to do is to make sure that I group it, and then I have now I have a keychain I can put in, or I could uh, put my key through and as well. So uh, that's one of the other keychains. I also quickly wanted to show you could make a math icon like this, um, and that has pi. So you'll have to add some structures in this, and I put some letters, but you can create some symbols like this, and you can add a keychain ring to that, and that could be your keychain as well. Last but not the least, we also quickly wanted to show you the protractor model. So in here I have the protractor model, which has all these pieces separately designed. So let's look at the top view, or yeah. So you have the 120-degree angle separately designed, 90, and so on and so forth. You have a 30. We have a 30-degree angle that I've designed, and then you have a 45. So you could pretty much design any of these angles and then place them on the protractor as I had shown you, and you should be able to showcase a three-dimensional protractor to the students who usually see it in a 2D format. And this is a project that was highly recommended by Haley, who is a mathematics teacher at one of our schools, and she's willing to share the STL files I also have the solar system STL file that we received from Michelle, who's from the Newton Public Schools. So thank you, Michelle and Haley, and we will share those STL files with you as well. Thank you. So this is where you will be submitting your work. So this is our integrating 3D modeling and printing website for this webinar sessions and the PD. So in order to submit your work, you will go to the resources tab. And in the resources tab, you will see the slide deck link from session 1, which was our face-to-face session. And you will also see the assignment submission form. When you go to the assignment submission form, it will ask you for information, and you can also give us the link to your Tinkercad project in here. So this is how you'll be submitting projects for your webinar sessions for session 2 and onwards. Thank you again. This is Rashmi and Haruna, and thanks for watching.